ISIS protocol, which is one of the oldest routing protocol that is to ever exist on the OSI model. So in this video we are going to talk about all the basic stuff that you need to know about ISIS. So without wasting much time, let's get started. So as usual, the content of any of the routing protocol that we had ever learned on this YouTube channel, so that will remain almost same. And for those viewers who might be first time for our channel or this video, you might watch the already existing protocols that we have covered, which is ISIS, including ISIS. So this is the first video on ISIS because we have covered already the BGP, OSPF and RIP protocols. So you can watch those videos. I'll have a link over here, or you can go through my to my channel and you can search from the videos or playlist. So for the content, it will remain the same. We will have an introduction, then the basics, ISIS history, following by the packet formats, overview using how the packets are exchanged, what are the packet exchange that happens to form a neighborship. Then at last we'll see how we can simulate ISIS with CPT and NS3. For the introduction part, we have seen so many routing protocols, including static routing. Then in the dynamic routing, we have seen IGP protocols such as link state, OSPF and distant vector RIP. We have also seen EGP protocols such as eBGP, and we have also seen the IGP flavor of BGP, which is iBGP, that falls over here. And this ISIS, it can fall under IGP and EGP both, so it will be under this dynamic routing, and it can be neighbor of or the children of this EGP and IGP protocols. So that is the introduction, or how where ISIS falls. Now let's get to know about a very high level overview of ISIS protocol. To start with the basics, intermediate system and intermediate system, that is nothing but the full form of ISIS protocol. It's very old and first routing protocol to ever designed for the internet scale routing at OSI model. Mostly it is used within the ISPs and inside their core infrastructure. So that's the main purpose of that's the main thing or main infrastructure where ISIS is being used nowadays. As this is one of the oldest protocol to ever exist at internet scale routing, for internet scale routing, so there are certain why and why nots to use ISIS. So you can also consider these as pros and these as cons. So we'll start with the pros. So as this is the standard protocol which is designed on the OSI layer, so that is very reliable. It is IP independent routing protocol because it is designed for the OSI layer, so it has its own addressing scheme, and it works on network access layer and internet layer, which is nothing but the layer 2 and layer 3 in the TCP/IP protocol stack. And then it is more scalable and stable because obviously it is designed for the OSI layer. Now there are certain cons also of using using ISIS, or why not to use ISIS, because as it is designed for the OSI layer, people usually lack of this ISIS protocol expertise in the industry, so that people don't tend to use ISIS. Instead of they use BGP or certain other routing protocols. So other than that, we are not able to provide features like modern BGP protocols because it is not designed for the providing feature rich routing protocol. Where if we talk about BGP, there are lots of different features other than routing also that we can use with the BGP, right? Then it's not designed for the TCP/IP protocol stack because it is designed for the OSI model, which is very old, and people don't use that. So that's why that is also one of the cons of using ISIS, or why not to use ISIS. And also it is hard to remember naming conventions that we usually use with the ISIS, so that we will see in the upcoming slides. So here we have stated some of the naming conventions that we use in ISIS. So here we have TCP/IP naming conventions, and here we have ISIS or OSI perspective of naming conventions. So we use PC, host or router. Those are referred as end system and intermediate system respectively. Also they are short form to ES and IS. Then we have something called autonomous system, AS, which is also referred as domain or AS in the OSI model. Then we have something called ARP, which is also known as hello in the OSI model. Also, those both are not directly related, but the work of ARP that is almost covered by the as hello. That's why we both we can say that they are equally having equally TCP IP and OSI naming conventions. Then we have something called IP protocol, so internet protocol, that is known as connectionless network service, which is also referred as CLNS. Then we have IP packet, which is also known as CLNP, which is connectionless network protocol. IP address, which is also referred as network service access point, NSAP, and MAC address, which is also referred as subnetwork point of attachment point, which is called SNPA. So as we discussed that ISIS has its own addressing scheme, so now let's get to know about what is the addressing scheme. So we have something called 3 sections or in the addressing scheme of ISIS that is used, and it can have a maximum length of up to 20 bytes. So it is divided into 3 sections, which is called area ID, system ID, and end selector. So area ID is usually the area in which the system is, and system ID is unique within the area, right? And end selector is a 1 byte value, which is either it represents that what type of node is, right? So whether it is end system or intermediate system. So usually it will be 00 because all of the devices are intermediate systems, or it can be 01, which is we usually use for end system, right? Then we have something called private address or area address family identifier. So if let's say we want to use ISIS inside the infrastructure, then we use this 49 followed by whatever the area identification that we want to use. This value area ID is variable. It can go from 1 byte up to 13 byte. This is 1 byte, so that is 14 byte, and rest of the 6 bytes are used by this system ID. So that's how we use the addressing scheme in the ISIS. So one of the most important part of ISIS, which is called routing labels and router types. So first we'll know about routing labels, so there are 4 routing labels starting with the level 0. So level 0 of routing, it happens between the end system and intermediate system, and the purpose of having this level 0 routing is to exchange the gateway address, and it is very similar to neighbor discovery that we usually see in the TCP/IP protocol stack. So that's the level 0 routing. Then we have something called level 1 routing. So the purpose of having level 1 routing is to form an ISIS neighborhood between the devices, between the intermediate system, those are in the same area. So that's the level 1 of 1 routing. Then we have something called level 2 routing, which happens between the intermediate system and intermediate system who are in the different area. So that is something called level 2 routing. And the purpose of having this level routing, this level 2 of routing, it is same. It is to form an ISIS membership, but between the devices, those are in the different area. Then we have called last type of routing, which is called level 3 routing, and the purpose of having this routing is to form an ISIS membership between the devices, those are in different domains, and it usually happens between the IS and IS who are in different domains. So you can see autonomous system X and autonomous system Y. Now very important part of the ISIS basics, which is called router types. So there are certain router types in the ISIS. So there are 3 router types. So first is level 1 router. Level 1 router is a router who is connected to or level 1 intermediate system that is the one who is connected to any other intermediate system in the same area and one of the end system in the same area. So you can, for an example, you can consider this router who is connected to intermediate system or the router in the same area and with the end system in the same area. So that is nothing but the level 1 router, and it has only level 1 LSDB, which is nothing but the mapping of system ID with the port. So that is nothing but the level 1 router. Then we have something called level 2 router who is over here. You can see this arrow, that is the level 2 router. So the router who is the only router in the particular area, that is called level 2 router, or you can also say that all of the interfaces of this router are connected to other router who are in the different area. So that is nothing but the level 2 router. and level 2 router will only have level 2 LSDB, which is nothing but the mapping of area with the port number. So that is level 2 router. Then we have something called level 1 and 2 router, which is this last type of router who has both of this level 1 LSDB and level 2 LSDB that we have seen earlier, and it is the router which is connected to same so the L1 router of the same area, and it is connected to any other router who is in a different area. So that is nothing but the level 1 and 2 router, and the responsibility of this router is to insert the default route into the level 1 router, right? So this is, we are assuming that it is level 1 router and it is connected to another end system over here. So that is nothing but the level 1 and 2 router. So I think that's it for the basics of introduction of ISIS. It might be a brochure or the refresher for someone who is already having an idea about ISIS, and someone who is new to this protocol, they might have an idea of how ISIS works in the depth. And yeah, we'll meet in the next one. We'll explore what are the packet types in the next video. So till then, keep learning and keep exploring.